Thanks. How does it work? You just need to press, right?
Yes.
Okay. Greetings, everyone. I am Tommaso Bendinelli. I am a senior intelligence engineer at CSEM, specialized in deep learning. And over the years, I had the privilege to work on a couple of industrial projects with customers on AI. And it's both exciting and challenging. And today, I kind of try to put my kind of what I learn in some takeaways for you that probably are useful if you want to jump, if you have some AI idea. I guess most of you have now, as everyone, or to just understand better the landscape. So before jumping directly, let me tell you something about CSEM. CSEM is a non-profit organization. It has offices all over Switzerland. And what we do, we act as a technology transfer between academia and industry. Our main goal is to support companies to develop new technologies. And in total, there are more than 500 employees. Not all of them are working on AI, but there is a larger group that is actually working on digital technologies. I'm part of this group. So my daily routine, basically, we work together with ABB or Stadler, this kind of company, for predictive maintenance, for instance. This is something that it's pretty popular, where we try to design an algorithm that tells you how to do maintenance so that you don't have to wait that the machine breaks to do maintenance. Or we do things such as really camera-based, so vision-based system, where the customers have specific problems, they come to us and we try to help them out. This is a cool example, for instance. In this case, the customer is kind of producing Laserban. It's like producing aluminum profiles. And what happens during manufacturing that sometimes they lose the correspondence between the aluminum profile they produce, the shape, and the serial number. So they ask whether we can develop an algorithm that just a picture can retrieve the serial number. So kind of deep learning. And this is actually working and is in deployment at the moment. So it's not just research. We really kind of try to apply it. And also another side of what we're doing is support system. That's how I like to call it. So kind of we work with for tasks that are right now just expert can do it. And then we try to figure out whether we can create an AI system that can support the task, because it's too tedious, so they want to scale up, and so expert are not enough anymore. And in this case, we work with Matter Toledo. I don't know if you're familiar with the company. They are producing these tools that essentially are calorimeters, and then they end up providing these curves. And these curves represent essentially the amount of energy that materials absorbs over a temporal spectrum. You can imagine water. What happens when it's kind of evaporating? There is some energy exchange there. And there are some phase transitions. You can see here, here, here. And essentially, at the moment, it seems like a trivial task, but you have many different materials, organics, any type of materials. It's really hard. And we come up with an algorithm that can do the task as good as humans. So you really can support them or automatize at least some cases. So you might be thinking, okay, a lot of things going on. How can you deal with all these kind of different projects? And the idea is that, and this is the first takeaway, that any machine learning project, any AI project, let's use the word AI, is kind of, you can really boil things down to kind of this pipeline. I think all the other presenters somewhat retouch on these steps. It is like data ingestion. So you really get the data from your customers. You try to load in your server. Data preparation is preparing data for training. And then model design is preparing the model, tweaking during the training, and then model evaluation. Then if you're not happy, sometimes, and most of the time you're not, you go back and you start again, trying to figure out where you made some issues. Otherwise, you go to deployment, and then you monitor the model. So that is the first takeaway. The second one, that each of these steps is paramount. It's really important. There is no step that you can avoid, and a successful project really implies that you've done all these things properly. And to show this case, I want to present two use cases. One is ChatGPT, just because I think it's familiar. We're all familiar with it. And the other one is a project that we did with the Gubelin. Gubelin Gem Lab is a company in Lucerne. And I want to show you, for these use cases, why each step is really important. It doesn't need an introduction, I guess. While Gubelin, what is the Gem Intelligence project about? So Gubelin Gem Lab is a company that essentially, their business model is they act as a certification company for sapphires and other gemstones. And essentially, the value of a gemstone really depends on where the origin is. So if a stone from Kashmir, for instance, it will cost 5 times more than a stone from Madagascar. And we're talking about millions. So essentially, it's really important to know exactly where the origin of a stone is. And at the moment, it is done by experts. And the experts have to look at the stone via microscope. They have to do some spectral analysis. They have to look at elemental analysis, so like just the chemical table, look at much composition. However, there is the gemstone industry is booming probably at the moment. And they came to us saying, okay, our experts cannot really keep up with the rate. Can you somewhat make a support system? So that's the idea. Here, I hope the goal is clear. We want to make a system that essentially kind of helps, or in some cases even replace, experts in this stuff. So this is the pipeline. Let's go step by step. So data ingestion and data preparation. I think it was mentioned before that this step is either it's offshore to poor countries or it's a really tedious job. And that's, I think, is why most of the time is overlooked at the moment. But it's really important to make this properly. Since, as we were saying, as the previous presenter was saying, the quality of the model really depends on your data. Just something about ChatGPT-4, for instance. There is like this interview of Sam Altman, the CEO of the company, with Lex Friedman. And he was talking a bit about what really brought the biggest benefits. And he was saying that data quality was by far the biggest factor. So it's not like making this figure even huge, it's just data quality. So then we move to the model itself. And here, I think it's clear to everybody that still the model is important. So I don't have to emphasize why this step is important. At the moment, we are assisting as kind of a standardization of architecture, especially when you have big data. You don't need to spend much time tweaking maybe like a layer, like trying to find the optimal combination of parameters. You just have enough data, kind of every model will work at the end of the day. So it's more, for ChatGPT, it's more like really the engineering approach of running this thing over a cloud. You need tons of engineers working on it. And as we were mentioning before, it's like millions of dollars. Like you do something wrong in the code and you have to redone it. You have lose millions of dollars. While in our regime, what we actually do in industry, we have much smaller amount of data. And hence what happens is that when you don't have much data, then the model becomes much more important because you want to give the correct inductive bias, it's called. Like the model has to kind of have already a good architecture for the data. And that's why it's important in our case. Then let's move to model evaluation. This is also something that it's a bit overlooked, I think. Like you might be thinking, okay, to evaluate the model, I just compute the accuracy and that's it. However, it's not that simple because sometimes you have to make sure that your metric really it's kind of meets what the customer expected, the stakeholder expected. And maybe accuracy is not the right decision. For instance, for ChatGPT, hallucination, so that was hallucination, they think of the model kind of say confident in something that is actually wrong, is something that is much more important. So they have designed metrics in that direction. In our case, for our project, we first started naively with the accuracy, and then we realized that the crosses here represent what the expert is doing, and here what actually the model is doing. We realized, okay, there is we can actually accuracy-wise, we're actually better than an expert, 2%. But then we started discussing with the customer and we realized that, okay, but the expert, most of the time, they just say, looking at stone, I cannot say anything about this stone. This is too hard. So we also took in account the direction of how many stones can actually be automated by our method over how many stones can actually be processed by the expert. And you realize that you have all different kind of metric that you ignore completely if you just consider accuracy. So it's really important to have like a big picture. Here is really going kind of looking at things from high above and making sure that you have everything under control when doing model evaluation. And then, last but not least, if you're happy with the model, then you deploy it. And it was mentioned before already that essentially models tend to age over time. It's not like the parameters tend to become older. It's just like the data distribution that you get tend to change over time. So essentially, ChatGPT is a perfect example. It was trained until 2021, right? Now more that we're moving in the future, he has no clue about that COVID ended or who won the last World Cup and whatsoever. So the accuracy will decrease over time. So it's really important to monitor so you can take action. If you don't monitor, accuracy will go to zero anyhow. In our case, with gem intelligence, just simply means that maybe these sapphire stones are being mined from new countries, and then we give to the algorithm, he has no idea about these new places where the stone has been mined, and that's an issue. So I hope this was a good second takeaway. Now let me jump a bit more about general principles, which we have there are general principles that we can apply to any AI project, and the answer is yes. And the first one, and I put this in first because it's really the most important one. It seems trivial, but apparently it's not. Is that in order to test the model, you need good data, not to train it, to test it. It happens many times, especially in a predictive maintenance project, that we get customers, and they're like saying, "Okay, I want you to make an algorithm that tell us when the machine is going to break, right?" And we ask, "Okay, how many instances, how many examples do you have in the machine breaking?" And it's like 2. And I'm shivering a bit because I'm thinking maybe we can find a solution for training this thing. Maybe we can find the latest Google paper that doesn't actually requires like instances of machine breaking. But for testing, there is no shortcut. It's really statistics. 50 years old statistics, you have some evidence there. So in order to test the model, you need good data. And also, this is also something that happens. Test data has to be annotated well. Most times happens that you have a model, and then you test on data, and the data maybe is a bit noisy. And what happens is that you get wrong interpretation. You think your model is wrong, while actually the test data is actually wrong. This was happening, for instance, with the GEM project, the Googling project. The stones were actually, we don't know the source or the actual place of origin of the stones because it's too hard. They are actually labeled by the expert. But if the expert is wrong, and then we're testing with the wrong, we have this kind of wrong interpretation, always the culprit. The second, I think the fourth takeaway is that AI, you need to be fast in prototyping. AI, and when I say this, all colleagues that are coming from a physics or mathematics background, which are kind of first, you can build from first principle, are always a bit sad, but they agree with me. It's kind of empirical science. There is no you cannot really understand what is going on in the model. So people, even the first practitioner, can come up with a new idea, and you cannot just tell him it is wrong, because it might be that's actually the best idea ever. And so you have to try as much thing as possible. And that's why when you're developing anything like that, you need to be fast in iterating. So it doesn't mean that you have to create like all over the place Jupyter's notebook and lose track of things, and then you don't know what is going on. It's just you want to make sure that you have the right tools, and then you don't have any unnecessary overhead. So in my case, for instance, we're not using Docker containers when we are doing the development of this thing. It's just not there's no necessity at the moment, and we remove some overheads. So that's a good principle. And last but not least, the algorithm in AI AI is completely different from the rest of software engineering, because when something does not work in typical software engineering, things breaks down. Here instead, you still get the model working, but it just gives you trash, and you don't realize this. And even worse, sometimes your test data, so the data that you never ever touch, the data that is just used as a proxy for then assessing how good the model is, ends up being in your training data. So you get even super high performance, and you're like, okay. And this actually happened to us. So again, in this project, at a certain point, we were getting 100% accuracy when the expert was getting 60%. And you're like, okay, I'm not the top AI scientist in the world. I don't think I invented something really new. So you have to be always critical. And indeed, instead of saying to the customer, look, the project is over, it was like, okay, let's go back and find the bug. Indeed, it was a bug, because if things seems to be too good, there is something that is wrong. That's a bit of thing. So yeah, that's